All right. So welcome everybody to our second in-person Node.js or JaxNode meeting for the year. So there were a couple of things that I was hoping to possibly present on tonight. We were just talking earlier that there's this new software for, I guess it's an extension for Visual Studio Code called Copilot. And I tried to get on the beta for that, and I was going to do that as a presentation, and I never heard back from GitHub. So, anyways, this is the backup presentation, but we're going to be covering some stuff. I think it's pretty neat here. So I just recently wrote a blog post about Async and Await in Swift, the Swift programming language, which is the primary programming language now in the Apple ecosystem. And we've actually had Async and Await for a number of years now in Node.js and JavaScript. And it's been in some other languages even longer than that. And so what I wanted to do is talk a little bit about, specifically about concurrency in software and show some examples, not just in JavaScript, but show some examples in some other languages of how they're doing this type of programming and why it's important. So with that, let's go ahead and get started. And so the first thing I want to do is mention that we are now doing live meetings again, and I'm looking for presenters. And I think somebody is trying to join. There we go. So I think we have one volunteer so far. And so if you're interested in doing a presentation for JaxNode, just let me know. I can be contacted through the meetup site or through my website, and we'll go from there. And so a little bit about me. I'm the co-organizer for the group. I also host a YouTube channel called the Polyglot Engineer, where I talk about these types of subjects and stuff on that channel. I have a GitHub page where I've got a number of different repositories that are publicly available if anybody wants to take a look at them. And I can also be found on Twitter either at the JaxNode handle or the Polyglot Engine 1 channel. So Async and Await. Async and Await is a really important paradigm that's been added recently to a number of different languages. But really what this allows us to do is do asynchronous programming. And with these two magic words, essentially what we can do is we can write programs that we normally would have if they were just a single or basically single threaded. But we can actually write our code now so that it'll work asynchronously, even though we're writing it in a synchronous type fashion. So it's a little bit easier of a programming paradigm. I personally think that if this is not in, right now this is being added to a lot of different programming languages, and I think it's just going to continue to be added into more different programming languages. And on top of that, I think these types of concurrency features are going to be added into the languages themselves. And so one of the big changes that's happened recently to the Swift programming language was there's a concurrency library that you could use for doing concurrency, multi-threaded programming, but it wasn't built into the language. They are building it into the language. And there's some reasons why that I'll get into. But it's been in some other languages for even longer than JavaScript. It was recently added into the Rust programming language. So I'm going to do some examples in some different languages so everybody can see what that looks like. So I think one of the reasons why a lot of people have avoided doing concurrent programming is because in the past, I would say it was actually pretty hard to do concurrent programming. It involved, having to create separate threads, and you had to know when to join those threads. You have to lock certain things to avoid, race conditions and stuff like that. So it's been kind of hard. And so the analogy I like to give is an analogy of a bicycle. and I don't know about anybody else, but the first time I tried to get onto a bicycle without training wheels, I was falling all over the place, and I wasn't having a really good time trying to ride the bicycle. And so what happened with me was that yeah, my dad had taken my training wheels off my bicycle when I was a little kid, and I couldn't ride the bicycle, and so I demanded my dad put the training wheels back onto my bicycle. And then my next door neighbor, who was a year younger than me, I saw him riding around without the training wheels on his bicycle, and I went back to my dad's like, "Get those training wheels off my bike! Get them off my bike!" You know. So one of the things that I kind of realized now, I wish somebody had told me this when I was trying to learn how to ride the bicycle, is that the reason why it's easier to stay, you know, upright when you're riding a bicycle when it's in motion than when you're just standing still is this concept of gyroscopic precession. And gyroscopic precession, basically what that means is when you have something that's spinning, like a gyro, as an example, and you apply basically pressure or force to that gyro, it's actually going to move in 90 degrees in the direction that you've tapped it. And that's where the force will actually be applied. So if you think about it, when you're riding your bicycle, if you start to fall over to the left, you don't turn the handlebars over to the right, you actually turn into that turn. And what you're actually doing is you're actually using gyroscopic precession to right the bicycle and keep you upright. And so that's the analogy I like to give. Once I learned that, it became a lot easier to ride a bicycle. But nobody told me. They just took the training wheels off, and I'm supposed to stay. How am I supposed to stay upright? So concurrency should be as easy as riding a bicycle. So now we get into the fun stuff. So why is this concurrency stuff so important? And I think the reason really goes into you know, software and hardware. So you know, we write software for hardware, and in particular, in order for our software to run, it has to run in some type of processor. And so our code gets converted into, you know, a machine language that then executes on these processors. So the processor I'm showing here on this slide is the Core 2 Duo. And one of the things that's important about this is one of the first chips that Intel did for the consumer market that had dual cores in it. And so, excuse me, I need to clear my throat. So basically what happened was, if you go back and look at processors, the CPUs that we're putting in computers and all kinds of different things, we got to a point where the CPUs got up to about what speed would you say your laptop runs at? How many gigahertz would you say, anybody here? How fast?
2 to 3 gigahertz.
Exactly, right? Well, if you look at the speeds that, like Intel, as an example, have been running the clock speed that they've been running their CPUs at, it's been at about 3 gigahertz for, I want to say, probably like a decade and a half. I'm not exactly sure when they initially. There are some processors that go a little bit faster for it, but they're starting to do all kinds of funky things where, you know, they're using water cooling into the machines, and they're doing all kinds of things to keep the processor from overheating, because they're trying to keep the clock speeds going as fast as possible. And so what the advancements that are still being made right now that are important is that, you know, Moore's law basically said that, you know, every 18 months, we're going to get, you know, twice the number of transistors added to a piece of silicon, you know, so it doubles every 18 months and stuff like that. So they're still able to do more and more transistors, and but the actual clock speeds of the processors haven't really improved. And so because of that, one of the things you're starting to see on, you know, most modern consumer processors, even the stuff that we have like in our phones as an example, like I have an iPhone right here, and I think this one's got 6 cores in it, right? And the way that Apple designed the CPU on this phone was that there's like, you know, 2 cores. I think they're like primary cores, and there's like then there's the other 4 cores are like low energy cores and stuff like that. So you can do all this stuff or process all this stuff simultaneously or in parallel to each other. And because of that, you know, to get the advantage, to get the speed advantage of that hardware, you have to write your software so it takes advantage of that. And so that's why that's important. So last year, Apple introduced the M1 processor. Does that have an M1 run it? Okay. So what's interesting about this is that this is using a different instruction set than the Intel chips. It's using a RISC-based instruction set, but it comes with 8 cores. It has, I think, like 7 GPU cores, and it's got some machine learning. It's got all these cores. They can all run parallel to each other. So to take advantage of that, you really have to be able to, you know, write code or have code that at least executes to take advantage of that. And this is the AMD Ryzen, and I believe it comes with up to 32 cores. So the companies that make these CPUs are starting to really deliver on, you know, basically being able to do multiple things. And I remember, 15 years ago, trying to write software to be taking advantage of multi-threading. And the pushback I was getting from the company I was working at the time was that, well, the problem we have is that, you know, we only have so many, you know, cores on the server, and they can only, you know, in theory, they can only have 2 threads running at the same time. So basically it kind of limited, but now there's servers and stuff that have, you know, 32 cores on them. So that brings us kind of like to the summary here. Our processors aren't getting any faster, but we are still adding more transistors, we're adding more cores to these processors. So the speed's really coming from being able to do multiple things at the same time. And the other thing I was going to just note on here is that the idea of concurrency, one of the things I started noticing about 10 years ago with Windows was that, you know, there was a couple of releases of Windows where, you know, it's like, well, this is a bum release. This is a good release of Windows. This is a sucky release of Windows and stuff like that. But I want to say around Windows 7, I started noticing when I go to install like a newer version of Windows on my Dell at home, it actually was feeling, you know, more responsive. It actually felt zippier, even though I hadn't, you know, upgraded the CPU in the machine. It seemed like Windows was actually running faster on my machine. And the reason for that was that one of the changes that Microsoft started making to the kernel for Windows is that they took a look at all the different calls that you can make in the kernel, and anything that took longer than 40 milliseconds, they started making it an asynchronous version of that method. So the idea is that you can fire off this method, but it's going to have some type of handle that handles the response. You're not sitting there blocking other things from occurring on the CPU. So they're starting to build these features into the end of the operating systems as well. So this example right here, I like this example because this is I think the first example that Ryan Dahl gave when he first introduced Node back in 2009. And so if you look at this, what this little bit of code is actually doing is it's setting up a timeout where it's saying we're going to console log, you know, world out, but we're going to do that in 2 seconds. And then right after that, we have a console log that says hello. So what will happen here is when we go to execute this program, it's actually going to write out hello first, and then it's going to do world after that, right? So the thing that really attracted Ryan Dahl to trying to do a version of JavaScript that would run outside of a browser was this whole idea of being able to do things asynchronously. And so this is something that's been built into the language since it was originally released back in 1995. But there's things that you can do with servers. It's a lot easier to do those things because you're able to do things asynchronously using JavaScript. So important thing to remember here is that Node.js is still a single-threaded runtime, right? So it is technically possible to spin up multiple threads with Node, but when you're writing a program, and you just have a program running by itself, it's not running, you're not necessarily running multiple threads. Behind the scenes, there may be things happening with different threads, but when you write your code, it's essentially it's a single-threaded application. So one of the things that's interesting about JavaScript is one of the reasons why it had to be asynchronous was because when they originally released JavaScript into the browser, when Netscape did, what were the prominent operating systems at the time? Consumer operating system. They were like Macintosh System 7 and Windows Windows 3.1. Were kind of like Windows 95, I think, came out the same year that Netscape Navigator shipped JavaScript. And so one of the things they had to do is that, if you're running or executing code in the browser and stuff like that, they had to make sure they did stuff, or they had the capability to not block the one thread, because that application was single threaded. And, at most you might have had, preemptive multitasking in some of the different operating systems, but it wasn't available in all the different operating systems. So it became crucial for JavaScript to be able to have this capability of being able to essentially do things asynchronously, even though you only had one thread that you can run the application in. So nowadays, when we run Node.js actually uses a system under the hood called libuv. And libuv is essentially it's a library, it's a C++ library that it's used for being able to essentially maintain like an event loop. And so one of the patterns you see, it's pretty popular in Node, is this concept of error first callbacks, or just callbacks. And then more recently, in the last couple of years, they've had promises as well that have been added into the language. So this is essentially what's happening behind the scenes. And Jitesh earlier, before the meeting started, actually kind of whiteboarded essentially what I'm showing on this one slide. But essentially what happens here is that when we run our program, right, we can send different types of requests to the event loop. And what happens is that, let's say it's something that is an intensive operation. Maybe it's something where we're trying to load a file up from the file system, or we're trying to query a database, or we're trying to do something that it's highly requires a lot of computation. Let's say maybe some type of machine learning type of algorithm or something like that. Those are things that could take a long time, and you don't want to block your program or block the event loop. And so what you do is you can register a callback. And what will happen is that event loop can continue processing things, like we saw in the first example I gave, where I had a console .log where it wrote something out. It's like I had code that I'd set up in a set timeout before. That was basically being handed off to the event loop, and the timer is basically waiting for that 2,000 milliseconds to occur before it goes and it finishes up that task. And so this is how Node is basically able to do stuff asynchronously and only have, in theory, one thread. So error first callbacks were kind of like the first way. So, or just I'll just say callbacks just in general. But one way of thinking about callbacks, essentially, it's just it's a function that accepts another function as a parameter, right? And so typically, what we'd see is, you'd see, like, let's say we have a function called query, and it's going to take in, arguments, and then the last parameter in that function is just going to be another function that handles the result when it comes back. And so one of the things I saw quite a bit of, and you can still see this in a lot of the APIs, a lot of the popular frameworks and stuff in Node.js, like if you're using Express.js as an example, when you go to write a route, as an example, you hand off a function to handle, the request and the response. So it's a very popular, pattern. You still see it. But one of the things that's interesting right now is that there's some newer frameworks and stuff that are starting to come out that are really starting to take advantage of some of the new features and stuff that have been added to JavaScript in the last couple of years. So this is kind of like a more realistic example of the error versus callbacks, which is, you'd have a function here where, it's going to do some type of long running process. So in this case, the make a database query here is taking some parameters, and then it has this CB parameter in here, and that CB is the callback. And then when we actually go to call this, we actually pass in our parameters, and then we also pass in this callFN function to handle the result. So that is kind of like the original way that we handled that type of synchronous functionality. But one of the problems of that is that kind of led this into what people are starting to refer to as callback hell, right? And we've probably experienced this where you're calling, you're making a call that takes a callback, but then there's another function that you have to use that's going out to, do something else, which also requires a callback. And then you basically wind up with these large tree structures of callbacks that are not very intuitive, right? And so this is an example of kind of what I'm talking about here. So here's something where I'm trying to read something in from the file system. It takes a callback that tells me, gives me the files for reading this directory, and then I can go through here and I can, go here, grab the file, do something where I'm doing some type of processing on the file. It's just a series of callbacks are being called. But if you look at this, this starts to form kind of like this big, tree function. It's not necessarily very easy to read. And it's one thing if you're the person who's writing the function, but then if you're working with multiple developers and you hand it off to the next poor soul who has to be able to try to figure out what you were doing and stuff like that, this can be kind of a pain. And there's ways of dealing this when you're using callbacks. Like one of the things you can do is actually define like an actual function instead of passing in a function. But one of the things that's really nice about having these inline functions inside of JavaScript is that you can actually use variables from outside the scope from where you're calling them. So, oops, do it again. All right. So that kind of brings me to promises. And so promises, I think, are a little bit slicker for being able to do things asynchronously in JavaScript. But at the end of the day, these are still, you're still kind of working with callbacks with this. They have a little bit nicer, I'd say, syntax where there's a .then and there's a .catch. And it helps the way that you write your promises and stuff like that, or the way you handle your promises. It's a little bit easier to read, I think, than the traditional callback. So this is an example of a promise here I defined. And then if you look at the constructor for this, it takes another function. This is essentially as a callback function that takes two parameters, one resolve, one reject. And these are the callback functions that get used for handling, handling the result. So if we look at this example right down here, we can see that now that I've defined my promise here, I'm calling promise.then, and then if this is successful, it'll handle the result. And this essentially what's inside of this then here is what's being handled inside of the inside of the resolve function. And then if we get an error here, then that's what would be handled by the reject. And another way of looking at this, this is, I think, a good example of if you're following the monad pattern in functional programming. This is an example of this where we can actually call then on a promise multiple times. And the fetch function, as a matter of fact, inside of JavaScript is an example of something that is that's a monad. So that brings.
I missed the monad part. Can you?
Sure. We go back. So if you look at this, we're actually calling .then on this twice, right? And so if we look right here, what we've done is, I'm logging out the value here, but then I'm also taking the value and I'm adding to and then returning that back out into the promise. And so now what'll happen is this is almost like a chain thing where I can chain these different values and stuff like that. And that's actually kind of handy functionality to have.
Is it fair to say that whenever we are doing chaining, we are using monads? No. Whenever you take the output of one function and make it the input of next through chaining, that's monad. What is monad?
Well, so there's a great quote from Douglas Crockford that I love, which is that as soon as any software engineer figures out exactly what a monad is, it becomes impossible for them to explain it to any other person. So, but that's essentially the simplest definition is.
It was possible for you before you understood it. You did know how to explain monad.
No, I never knew how to properly explain it, but I recognize the pattern. Yeah, but that is an example of one. But one of the best explanations I heard was that if you're using or you have some version of flat map in your your code, like for instance, the promise has some concept of a monad, or sorry, the monad has some concept of a flat map, then it actually is a monad, as an example. So the stuff you were talking about before with the generator, the API you were writing, stuff like that, where you're able to kind of like take a stream and then be able to do transformations of that as you're getting and stuff like that, that would be an example of a monad. At least I think it is. So anyways, like I said, Douglas Crockford said that, once you understand what a monad is, it becomes impossible for you to describe to anybody else.
Douglas Crockford is the guy who wrote the most famous book on JavaScript. JavaScript, the good parts.
That's right.
So he's considered somewhat, he's a little dated now. So he was famous like more than 10 years ago, but he's still one of them.
David, can you go back to the previous slide with the
Yes.
code? Can you just help me with two? What is the sequence that this code is executed in the computer versus what is the sequence of events that I see the output on my console?
Okay. So the sequence, the way you'd see this output on your console is the first thing that you would see is you would see a 1 being printed out to your console. And then the next one that you would see would be 3 being outputted to your console. And the reason why is because when you're using this .then, basically what you're saying is that the first thing that this promise is going to output when it resolves, what's going to be output is what is going to be executed. And then if you do a return, what that will do is it'll essentially allow you to return another then out. So for instance, by doing this return here, now we can use this .then again. And essentially it takes that and executes that as the next thing to do in the promise. Does that make sense? We're going to show some examples a little bit later. So
Thank you.
that'll help. So that brings us to Async and Await. So Async and Await's actually been in JavaScript or at least in Node since version 8. And the way that works is that you take your function and you put async in the front of your function, and that will make your function asynchronous. And then any place where you normally have to use, like let's say a callback, for instance, let's say you're using a promise as an example, you basically would just put await in front of the method that was returning a promise. And what your code will do is it actually will wait for that promise to execute before it continues executing your code. And this allows, to write code that looks a little bit more synchronous. It's a little bit easier to read. This is also available in C#. It was just added into Swift 5.5. So it's going to start showing up in iOS, iPadOS 15, and macOS 12 in the fall. The betas are out there now. So if you're in the Apple ecosystem and stuff like that, you can start using or start writing software for this stuff today. But you won't be able to run your programs in it until iOS 15 and macOS 12 come out. And this feature is also in the Rust programming language. And I'm going to show examples of all of these so we can see what these look like. So
if I may add one thing to the Promise API thing, is that one could think, it might help to think of the promise is like a piping system where the resolve, think of it like a pipe where one side is pulling out of the pipe or sucking, the other side is pushing into the pipe or blowing into the pipe in a way. And promise, so that's the system that Promise API provides. Now, if you can go back to your code. Yeah, so here, the Promise is providing that piping system. The job of resolve and reject, both of them, is to push into the pipe, and the job of then is to suck from the pipe. So then is basically gets blocked until there is something in the pipe to pull out of the pipe. As long as there's nothing to pull out of the pipe, it just blocks. And then the resolve or reject, both of them, they can push in a value into the pipe, like a channel, or effectively. So resolve. So now, basically, promise.then is like you're putting a cap at the sucking end of the pipe, and the promise.resolve is you're pulling something you're pushing something into the pipe. And then, so with .then, you can block yourself until there is something to get out of the pipe. And then .resolve is where you're putting stuff into the pipe.
I like the pipe analogy. All right. Whoops. I'm doing that. So the way that Async and Await works behind the scenes is that if you think of V8, the compiler behind JavaScript, is that what it's actually doing is it's taking your methods, your functions, and anytime you denote it with async and you have an await in your code, it's actually breaking your function up into multiple functions. So it's going to, behind the scenes, it's going to take that and it's actually going to create a callback in its intermediate code that then handles the result and then returns it back into the body of your function. And so essentially what that does is that streamlines how we wind up using JavaScript or these other programming languages. But essentially, every time you put an await inside of your function, what it's doing is actually it's breaking that function up into multiple functions. Oops. Apologize for that. All right. So here's an example of a promise. And this is a point I wanted to make that's pretty important. In JavaScript, promises and async and await functions are interchangeable. They're completely interchangeable. And when you write a asynchronous function, essentially you are writing a promise. So if we look at this example right here where I have this function here that's actually returning a promise, if we look at this async function right here called async call, what this is doing is it's actually taking this resolve after 2 seconds function that I have up here, and I'm just placing an await in front of that. And so what'll happen is what's being returned here with this resolve will actually be handed back to this result right here. And you can almost think of this as like a semaphore, where you can essentially you can get a result back. You can spin something off asynchronously, but then get a result back. And this is what await allows us to do. So if we look at this, if we go and call this function, what will happen is we will see, console.log, it'll do calling, then we'll get resolved, and it'll output the resolved is the last part of that. And this is an example of what this looks like inside of a module. And so one of the things that was recently added, I want to say Node 14, they have this concept of top level async. And so when you go to write your JavaScript code in a file, as an example, and it's set up so that it's running as a module, you don't have to start the function off with async. Any line that you have inside of that file is going to be treated like an asynchronous function. So if you look at this example right here, we're doing essentially the same thing we were doing before in the previous slide. So you can see that we have this async function. Here we don't even have a function. We're just basically calling this stuff, and we would get the same exact result as we did in the previous if we ran this as a module. So some considerations here is that I think nowadays if you're designing APIs, I would say that it's pretty important to make sure that you have promises built into your APIs, because the developers and stuff that are going to be consuming your APIs or want to be able to use Async and Await. And so as long as you're using promises, you're going to be able to take advantage of that. Even if you're not, there's still ways that you can do it. You can take there's a utility function in JavaScript in a node called promisefy, where you can take any callback and turn it into a promise. And it's also pretty easy to do that on your own as well. And like I said before, the node process itself is actually a single threaded process. So just putting async in front of your function does not make the function any faster. It just makes it asynchronous. So that's another consideration. So some of the other languages that have this feature, I mentioned C# and I think Swift before, but F# I think has had this for like well over 10 years. So that is a feature. So if we look at this example right here, I'm by no means an expert on F#, but you can see here that they have this async keyword in front of this block, and then they have this await task inside of here, and that's essentially how they're doing async and await inside of F#. And C#'s had this, I think, close to 10 years. And one of the key things to remember about C# is that if you're going to be using async and await in C#, it's usually used in conjunction with tasks. So if you had a function that would normally return an int, like what we have here in this example right here, you can see that we're using the task and a generic event so that it knows that the result that's going to be handling for this is actually going to be an integer. And so that's the one construct you have to remember when you're using this with C#. And I'll show an example, like a real world example of this. And this is an example of doing something very similar in Rust. So just like in JavaScript, you can denote your function with async, and in Rust, functions are you just use fn for a function in Rust. And then you have your return type here at the end. And then any place where you're going to be doing an await, or you have a function that you're calling inside of Rust that's doing await, you do .await here. And you can see they have two examples here where they're using .await. And I'm pretty sure that the interesting thing about Rust is that they use the same compiler technology for Rust they do for Swift. It's actually, they're both based off of, the compilers are both based off of LLVM. And so I believe they're using the same basically stuff behind the scenes for being able to generate or compile the code for doing stuff asynchronously. So here's an example of how this would work with the Swift programming language. So Swift's a little bit different. You don't begin the function with async. You actually put it after the function name or before the return type. And then any place where you're going to be making a call to something that would be asynchronous. So in this case, he has this load web resource, decode image. These are all things that would take a long time to do. They also have await. So one of the things you'll see here in these different examples is that the concept is pretty much the same with all these different languages. It's like you usually in the signature for the method of the function, you have a sync in there somewhere. And then any place where you normally would use a callback, you just basically put await in front of that method call. And there's another function I like a lot. And so unlike JavaScript, Swift is not single threaded, right? So you can take advantage of multiple threads. And so one of the things they did, I think was pretty slick, is they have this, they have a whole new model type that's called an actor. And so actors are not new. They've been around in some different systems. Like there's a very popular framework in Java, I believe, called Akka, where you can work with actors, and it's meant to be a very, it's meant to work with multiple threads at the same time, and without having some of the traditional problems that you might have with like race conditions and that sort of thing. So one of the things that's pretty interesting about what they did here with Swift is that inside of your function, anytime, let's say you want to spawn off a new thread, you can actually, in this case, where they're creating this first photo, second photo, and third photo, before the let, they have the sync keyword before each one of these. And then what you can do is you can do an await, and you can see here, they're just treating this as like an array, all these different things coming back. So what'll happen is these will all spin off into their own individual threads. And then on the await, it just joins all those back together back into the originating thread. That's all you have to do to be able to do that type of a workflow. And so I think that's pretty slick. And so, Apple, I think, is just getting started with some of this stuff. But the key difference here between what they were doing before and what they're doing now is all of the synchronous, all the concurrency features, all the multi-threaded features and stuff are all built into the language. You don't have to use a separate framework for managing that. You can just use these keywords and it will do all the stuff. But it's even smart enough to know, okay, well, I'm going here, I'm trying to do 16 different lets, but I only have 8 cores that can process all this. It will compile your program so that it's smart enough to only use the number of cores that are available to it, and it manages the rest in the system. So I think it's pretty slick what they've done with it. So with that, let me go ahead and do a demo. Yeah. All right. So the first thing I was going to do is I'm going to show you an example program I wrote tonight. And so I don't know if anybody likes stand-up comedy, but there's a comedian I like. His name's Stephen Wright. And you can do this yourself. You can go to writequotes.rokuapp.com. There we go. So this program, essentially what it does is just generates a different quote every time I go to call this. But what I did is I wrote an API, a backing API for this. So if I can move this out of the way. So for instance, if I come over here and I type in, I can type, there we go. So I come in here, I type in quote and say random. This actually has an API that I can call where if I want to write a client that just goes to consume the quote directly, I can just come over here and I can call this random. I also have one where I can specify the ID of the quote. So come in here, then I can just pull back individual quotes if I want to do that as well. So let me come over here and I'm going to go into this .NET example here. So let me go ahead and open up code. And I'm going to blow this up so we can see this a little bit better here. And so this is a client that I wrote that goes out and uses an HTTP client to essentially call that same method that I wrote. And what it's going to do is it's going to, this is all using, it's using a synchronous task right here. And then there's two things here that are using an await. So I'm going to call this, use the HTTP client to actually call that resource. And so since it's a network request, it may take a while. I'm actually using the await keyword on that. And then it's returning back some JSON. And so I have another await here that's actually going to take that and convert this into a quote that I have right here, where I have a property that assigns the quote and deserializes that into this object. So let me try running that and see what happens. So the way you can do that, I'm using .NET Core for this, so I can run on the Mac. Do .NET run. And there, we can see it came back with a quote. I can do that again. And there's another quote. And I also did this in Rust. So here's the program in Rust. Let me open this up in code so it's a little bit easier to read. So here's the Rust program. And so very similar to the .NET program, what it's actually doing here is it's going out and it's making a request using the request library. And then it's calling it, it's doing a .await on that. So what happens once it gets back the quote, then what it's going to do is it's going to try to apply JSON hash map to that. And then it's doing another wait on that. So we have two awaits that are happening here. So if I want to go and run this example, with Rust, you use a tool called Cargo to do, your creation and building and running and stuff like that. I've already built this, so I'm just going to go ahead and, I'm sorry?
Like NPM.
Yeah. And so here, it generated a quote. I'll do that again. And so that's the example in Rust. Now I'm going to show what this looks like in Swift. All right.
Come on, man, I was trying to understand that joke.
I'm sorry. Well, it's available on the internet, so if you want to go and play with it after.
A particular joke. Now.
I'm just kidding.
Oh. So what I did here for this example is this example is actually using the Star Wars API. So if you're not into humor, but you're into Star Wars, you might like this one better. This one, what this does is it goes out and it gets a list of different starships. And so what I did for the first method here, I had this function here, and this is the way that, I'm currently writing methods inside of my iOS application. So in this case, the client here is the URL session. And I'm passing it in a URL. And you can see here that it takes a callback. And there's all kinds of different ways that you can introduce bugs with the way that callbacks are implemented on iOS. But there's some error checking that we're doing here just to make sure that there aren't any errors that are being thrown. And then what will happen is once we get our data back, it's going to try to decode that into a model that I've predefined here. And then it's going to display that. So if I come over here and run this, there we've got we've got some different things. But what I did just to show how much easier that this function is to write with the Async and Await is I have this refreshable and this on appear. And what these are actually doing here is when we go to do the on appear, this is essentially the same function as before, but here we're actually using async and await to get the data back. And then we're decoding that, and then we're applying a map to that and assigning it to this array that's being used to display these elements here. Yes. How's that? That should be a little bit easier. Of course, with this screen, probably helps if I do that a little bit. That's probably a little bit better, right? Okay. So this is essentially, how you can write asynchronous stuff using Swift now. I think it's pretty night and day, the difference here. If you're trying to write something where you're making a network request, getting results back, and handling that, this, is what, maybe 7-8 lines of code compared to this. And plus, this is using a block or a trailing closure to handle the results. So I think this one here on the top is a lot easier to read than the one here on the bottom. All right. So are there any questions?
I did have a question about the Rust code. I mean,
sure.
It's more from my interest in Rust.
Sure.
Can you bring it up?
Absolutely, yeah. There we go.
Can you make the font much larger?
Yes.
For blind people? Yeah. All right, so this is that request you're calling. Is it being imported somewhere?
Yes. So if we go here into the cargo.toml file, you can see here I've brought in a couple different dependencies. And so this is similar to the package.json and Node, where you can specify different dependencies.
Mm-hmm. Yeah, but I understood that part. What I don't understand is that is you pulling that code, including its output. I don't see you pulling that code into that file main.rs.
So some of this stuff I'm using, some of it I'm not. So the Serde is a...
No, that's not what I'm asking. Can you go back to main.rs?
Yeah.
I'm asking. I don't see an import statement for request.
Yeah, has to.
So I think a lot of that's going to depend on how the module is written. So if the module is written, if it's like a top level module like this is, you don't have to do a use to import it.
Oh, I see.
But in the case like where I'm using HashMap as an example, that's in the standard library.
Okay, that means request is the namespace. It's not coming from a namespace. It is the namespace.
Yes.
So you are fully qualifying. The get is what is coming from that namespace.
Yeah. In other words, if there was a something inside of that you wanted to call. So it's a little bit different. It's not like C# or Java where it's a traditional object-oriented language. It's more like Go or C in that sense, where it's a procedural language, but it's not, and it uses types. It has a strong type system, but it's not like a traditional object-oriented system. You can write objects, but it's probably closer to C. And it's actually the goal. There's a lot of different programming languages that I've seen where the goal of the programming language is to get rid of C. And one of the reasons for that is because a lot of the bugs that you see in a lot of modern systems have to do with memory management and this whole idea of ownership. And one of the things that Rust does very well is that when you assign a value, right, to a variable, as an example, and then you want to go and assign that value to another variable, let's say it's the same variable, essentially what you're doing is you're giving up ownership. By default, it won't allow you to do that unless you use the MUT keyword in the language. I'm by no means an expert on Rust. It's something I'm interested in because I played around a little bit with Go, and I don't really like Go. So I certainly like some of the features in Go, but as far as it being a replacement for C, I don't see Go as being a replacement.
Oh, yeah, definitely. Anything that depends on a garbage collector.
Yeah.
It's not going to be.
So what's interesting about this, I think this is one of the reasons why this is better than Golang, is the compiler technology that Golang is based off of GCC, which is an older compiler technology. This is based off of LLVM. So it's essentially, it's the same compiler technology that CLang is based off of, and also, you know, all of Apple's suite of
when
tools.
he says CLang, he doesn't mean the C language. He means Clang compiler.
Clang compiler, yeah.
And of course,
My bad. But yeah. So one of the things, Chris Latner is the same guy behind the Swift programming language, is the same guy behind LLVM, right? He started, he's a graduate student. He worked on LLVM, and he actually got hired by Apple because there was an Objective-C mailing list where he sent out a question. He was asking about, you know, hey, has anybody tried, you know, adding Objective-C, you know, to as a C, you know, to a C compiler and stuff like that, where we want to add Objective-C to LLVM, and that caught the interest of Apple, and Apple hired him, and he did all this work at Apple. And one of the big things he did in LLVM as well as in Swift and Objective-C is that at one point, a short period of time, they actually added a garbage collector into Objective-C. Is everybody here familiar with what a garbage collector is? You're not? So essentially what a garbage collector is when you are going to create something in memory, right? Unless it's on the stack, right? Unless you explicitly tell the system, okay, I'm done using this, it will leave it in memory, right? And so what will happen is as you're running your program and it's going to declare more variables and more structures and stuff like that into memory and stuff like that, it'll eat up all your memory unless you tell it, okay, I don't need this anymore. And C and C++ as an example, you have to use these different functions like free and malloc and stuff like that to declare memory and to free it up once you're done. And what happens is the people who are writing the software, at least right now, are human beings, and they forget. It's like, hey, I need to get rid of this now that I've created it, and they wind up creating memory leaks and bugs and all kinds of other problems and stuff like that. And so one of the things they've been trying to do in some of these newer languages is they've been, you know, initially garbage collection was kind of like the solution. So JavaScript, Java as an example, C#, Visual Basic.NET, all use garbage collectors. And so the garbage collector, essentially, it's part of the runtime, the system they use when they're running their intermediate code. It says, okay, she's done using this variable. We can now remove it from memory, and we don't have to worry about this having a memory leak. And garbage collection actually works pretty well. Just as it's going, it uses a run loop as well, where it goes through and it tries to cycle and remove these variables. What happens is if you have a program that's using a lot of resources, as an example, sometimes that system is not able to go out, and it doesn't have the availability to go in and basically remove that stuff from memory. And so you can still wind up having these memory leaks. And there's even stuff where, like in .NET as an example, when you're going to declare something, and it's something, let's say it's a library or whatever that was written natively, it was not written in .NET as an example, you have to explicitly let the compiler know that, hey, I'm using this right now, but when I'm done, you need to dispose of it. So there's extra work that's put on the developer.
The garbage collector is kind of automated
Exactly.
JavaScript, whereas in some of the other languages,
Yes.
you have to tell it.
Exactly. So Chris Latner was not a fan of garbage collectors. And one of the things that, like, when I first started writing iOS software is that you had to use any object that you created, any Objective-C object that you created, you had to manually call release on it. So once you were done using it, you would you'd call release on it, or you could do auto release. And so what they did was they never allowed you to use the garbage collector on iOS. You could for a short period of time, you could use it on the Mac, but they never allowed you to use it on iOS because they're afraid that it was going to eat up too much of the limited processing power they had on the early iPhones. Now, an iPhone's got a faster processor than most, PCs, but back then it didn't, and so they didn't want to eat up all their CPU cycles trying to go through and get rid of memory and stuff like that they didn't need. And so what they did was in the compiler, they built the release into the compiler. So in your code, let's say you go and you declare a variable that's inside of a scope of a function, as example, and once you're finished calling that function, it's no longer necessarily has to use that variable. What they did is in the compiler, they automatically put a release into the compiler. So when it's going to compile your code, the compiler's smart enough to go, okay, we can delete this now. And they found that that's a better system than trying to use a compiler. Just build it into the compiler. Don't have this separate system that has to run to free up memory. Just build it in, and then you don't have to worry about it. So Swift, Objective-C, and Rust now, they all use the same compiler technology. It's all based off of LLVM. And so I believe that what they did, the Rust developers, is they built this, they use the same functionality in LLVM where they did it?
Okay, so LLVM is the backend.
Yes.
Okay, the compiler backend.
Yeah.
The automatic memory management that Rust provides is in the compiler front end. Rust language itself.
Okay.
So LLVM cannot help much, cannot provide automatic memory management. Now, garbage collectors do provide automatic memory management, and they could be able to, they could provide automatic memory management in the backend itself, because of the stage at which they work at runtime, that is, right?
All right.
So, if LLVM were to add garbage collection, then not all, but any language that relies on the concept of garbage collection will benefit. But the way Rust works is it provides automatic memory management at compile time, at build time.
Yes.
And so it is injecting. So it keeps track of where you are assigning variable values, etc., and more importantly, where you are transferring ownership of memory, as you know. I'm sure better than. But so it's keeping track of who owns a piece of memory, which piece of code, and then it's keeping track of when does that piece of code go out of scope, at which point it will inject that piece of an extra piece of code to release that memory.
Yeah.
It is also keeping track of when one piece of code hands over or transfers the memory ownership to another piece of code, then it knows that I'm not supposed to put that release code at the end of this one, but at the release code at the end of the next one, whoever took ownership.
Yeah.
All of this happens at compile time. And again, LLVM LLVM in and of itself cannot keep track. It's the compiler front end, the language compiler, which is the front end, the Rust.
Yeah.
The Rust specific one.
LLVM is not one tool, it's a whole set of tools. And so my thinking is that, even though they use two different compilers, that, they took the ideas and stuff that, they'd applied to Clang with Objective-C and apply that into Rust. It's the same idea, right?
Same idea, yes, but I'm not, yeah, I totally agree. But I don't think LLVM is what is providing automatic memory. It's the language compiler front.
Okay. So one of the things that I've heard Chris Latner say recently in an interview was that one of the things that they want to do in Swift is add the same ownership model to Swift. In other words, there's really not a concept of ownership in Swift like there is in Rust. And so, they're looking at some of these ideas that they've had in different languages and they're adding. So Async and Await not like something that, Apple invented. It's something that's been around for a while.
Was it there before JavaScript got it?
Oh yeah,
Is
yeah.
it borrowed from someplace else?
So I think the first language it really kind of showed up in was Haskell.
In this form?
Not necessarily in this form, but I mean, Haskell is quite a bit different from, what I consider to be like the C-like, languages and stuff like that. But it was in Haskell, I think easily like 15 years ago or something like that. And then in F#, when they were developing F#, F# is a functional programming language. And I think they copied a lot of stuff from Haskell. And so they do have like an async keyword that you can use in
other
F#.
programming languages, and I forget which ones, but they have the concept of continuations, which is almost the same thing, except it's more explicit where one, it's like yield and block and those kinds of things. So yeah, but yeah, async await, the way it has been implemented in JavaScript is like perhaps most cleanest that I've seen. It's very beautiful.
Yeah.
It's like nothing, at least I haven't seen anything cleaner than that. I have seen Go has channels. What? Oh, okay. Yeah, Go has channels, asynchronous channels where they work just like pipes. You push from one channel, it pops out of the other. Well, no. You don't push from one and it pops out. There is a writer to the channel and there is a reader from the channel, and they are just like pipes. But it is nowhere as readable as this one.
So this is the index.html for the example application I wrote tonight to get the Stephen Wright quotes. But this is an example here where, this is all in the web page, and I just made a immediately executing a function here for the async function. And then you can see here, I'm using the fetch API, which is a web API. It's available in the web browser. And then I'm calling await on that, getting the results. And then when I get the results, I call the .json off that to get the JSON translation from that. And then I'm pulling the code off of that, and then I'm applying it to this div that I have inside of here.
How do you join the Zoom?
I'm sorry?
How do I join your Zoom?
Oh, join my Zoom? I should have sent out I meant to send out the instructions. When I sent out the email I sent out yesterday, it was in there, but I can.
Okay, yeah, okay, send your email from yesterday. Thanks. Go ahead.
No problem. So, I think this is what's really slick about this is that, you can see this is pretty simple. You could do this pretty simply as well with a callback. So if I wanted to rewrite this as an example, I could do it like this. I could just come over here and I could say fetch and then pass in this quote. And I could say then. And then in the result, I can do is I can say return result.json. I call .then again. And we could say JSON. And in this case, what I can do is I can say, I want to take the quote off of that, and I'm going to do is say quote div, or HTML, and we'll just say JSON.quote, and it can come out. These out. That's my regular keyboard. I can get rid of that. And this essentially does the same thing as the code I had before, but you can see here, I'm just having to use this series of different .thens, because the fetch is a promise, right? So when I'm calling fetch, I can call this using the, just passing into these different callbacks inside of each one of these different thens here.
Now, allow me.
I'm sorry?
It's no,
Zoom? I'm
it's
sorry?
not a promise, right?
There's no, yeah. No, not me.
Oh, admit, sorry. There you go. I'm
So
sorry, there's something about a promise?
When you change the code to the current state, it's not asynchronous anymore, is it?
It is asynchronous because the fetch API is an asynchronous API. And so every time we're calling .then, basically what's happening is we're basically saying is we're passing a function. This is an inline function that we're passing in here. And we're saying it's like, once you're ready, once you have the result that we need, use this to process the result. And so another way of writing this would be, we could say function, and then result. And yep. So that's another way that we could write this. We could do the same thing down here. We could say function JSON, and essentially does the same thing here. But these are callbacks. So we're having to pass in, callback functions into this as part of the API. And one of the things that I like about Async and Await is that, I want to call something and then get a result back from it. I don't want to have to pass another function into it to do something with it once it has the results. I can just get that back and do anything I wanted to with it. So if I come back here and I make this async, I'll go ahead and delete this.
So yeah, I mean, async await is so much more readable than.
Okay, so was that your purpose, was to show how to do it the hard way or the non? I don't know.
It's multi-purpose. So one of the things I wanted to show was that there's actually, there's two things I want to show. I want to show that this whole concept of sync and await is something that it's in JavaScript now, and it's in some other languages, but I think it's going to start showing up in a lot of different other languages. So I wouldn't be surprised, like within the next 20 years, they add it to Java. So we'll probably get that as a feature in Java like 20 years from now. It's something they've been trying to add into Swift. So there's kind of like something that was called the Async Manifesto that Chris Latner wrote like 4 years ago, where he outlined Async and Await, actors, all these different capability of being able to do things asynchronously, basically multi-threaded stuff very easily inside of the language. And it's taken Apple this long to actually implement it. Yes.
The thing that we were discussing over there?
Yeah.
While we were doing, I implemented it. And I have a little bug that I could use some crowdsourcing.
Do we want to share the screen?
Yeah.
Okay, let me do a new share. Oops.
So let me share.
I'll make you the presenter.
So, okay.
All right.
Okay. Have you given me?
I'm making you the host.
Yeah, I can hear you.
Okay, so am I sharing my screen? No. Oh, no, I'm not. So hold on, let me share the whole screen. Is there a way to share? Okay. Yeah, let's stop it. Okay. Let me know if you guys can see.
I can see it.
the screen.
Yeah.
Yeah, one second. As soon as I figure out where I am. Okay. So one second. It's I'm a little lost. All right. So for those who were not part of the discussion before we started, basically, I was asking these guys if they have heard of generators and async await for await thing. So this is a bunch of code, but I don't want to. If I show you this, let me just show you. So I have this. The log and delay are utility functions. Logs with a timestamp in front, and delay creates a delay, like blocking delay. Okay. All right. So let's skip over those. Okay. Then this get orders is a, as you can see, it has a star in front of it. It's a generator function. We'll get back again. So this is the one that is taking time. It just blocks and waiting for orders and they need to be processed. Pack orders is another generator function which reads from get orders and then has its own delay and packs them, and then quite importantly it yields the order for the next guy, whoever else calls him to do that. And then ship orders is consuming the order. At that point, it's kind of, let's say if there was more activity after that, you would yield again. But imagine that there is no activity. There is only there's get orders, pack orders, and ship orders. Let's say 3 things. So, and now at the very end, at the top level of the program, I just call ship orders. And ship order, if you see let's work our way backwards into the system. Let's start from main. So this is our main. It ships orders. Well, you're not going to ship an order that's not been packed yet. So you say order of pack orders. So now, if you are familiar with the for loops in JavaScript, that's what this is, basically a for loop, which expects this guy, pack orders, to return an iterable of orders. Could be an array, could be other kind of iterable. And then it iterates over it. So every time an order is returned, it goes into this loop. Okay. Notice that there is an await in front. This is for await. So imagine if you want to understand easier, just read it like this for now. And imagine that pack order is not an asynchronous thing. It's just a synchronous one that returns an array of packed orders. So this will be easier for us to understand, right? So this guy, ship order, is returned an array of already packed orders, and you just went through them. Now I'm simulating, imagine that your shipping takes 1 second. Okay, and then so you say, hey, I'm shipping this order, and then you spend time actually shipping it. And that's where the await delay is happening. And then you say, okay, I'm done, shipped it. Now let me bring back for await into this. What for await does is, it says, unlike a regular function that will return you an array of orders, I am expecting my pack orders to be a generator function. A generator function does return, instead of returning an array of orders, it returns a stream of orders. What's the difference between an array of orders and stream of orders? An array of orders, it gives you all the orders in one shot as a snapshot in time, while a stream of order, all those elements are separated by time.
Continuous.
Huh?
It's continuous, right?
It's not continuous. That's the whole. I mean, it is. You could. I mean, there is a built-in delay between elements of that iterate. Okay, so that's why you have to do for await. And now if I go to pack orders, Pack orders is two things. It's an async function and it is a generator, and these two are separate things, almost well, somewhat related, but you could be generators and not be async. And of course, you all have written functions that are async but not generators. So the reason why it has to be async is because it is awaiting on something. And the reason why I wrote it as a generator is because I want to yield values from it. And that's the crux and essence of a generator. A generator is a function that returns multiple times, like a stream would, right? Any stream needs to return values multiple times. And a general expectation is that a generator yield value multiple times, returns multiple times, and they're separated in time. And so that way you can yield something and then go back into the loop, get busy doing something else, and not return anything, not yield something for a while, and then eventually you yield again when you're ready. And you keep doing that. So now, so what is happening is this generator function itself is depending on another generator function. Okay, so it's just like the previous one. It's also for await, and get orders is yet another generator function, because your orders from your website are not coming continuously, like endlessly. It would be nice to have an e-commerce site that has continuous stream, endless flow of orders, but most of us don't have that. So there will be delays between two orders are spaced out in time somewhat. So that's why you have to have for await and then this get orders. Again, get orders is not going to return an array of pre-existing list of orders, but something that comes over time. So that's what get orders is doing. And then we are doing the same thing. As soon as I get an order, I say, okay, I'm starting to pack the order. And then it takes some time, let's say, in this case, 1,000 milliseconds again. And then it says, okay, I've packed the order, and now I'm yielding the order. Yielding as in, here's over to the next guy who's awaiting on me, or for awaiting on me, more likely, because I'm good, okay? So you do that, and then get orders is predictably like any other, generator function. In this case, just for demo purposes or for marking up purposes, I put orders in an array pre-existingly, but I don't return them immediately. I just return them over time through a yield. There is no for await in here because it is not reading from a generator. It is reading from an array. And then I put in a large delay of say 5 seconds. And then he says, oh, I just got an order. Let me yield the order. And whoever is for awaiting on me will get it. So with that, now this is the overall. Let me also explain these two. This is more from the viewpoint of people who want to understand A, variable args in JavaScript, and B, how to create a promise out of non-promise, things that are not promise based. So so this is a general purpose log function. All I wanted to do a console.log, but I also wanted to automatically inject the timestamp in there. So the way I did that was, it would be nice to say, oh, all right, I am going to, you could write this function as function log as, the message to print, right? And then you could say console.log, and then you want to print the current date timestamp. So you say date.now, and then you print message. Okay, this is one way to do it. This is a very simple way. Everybody knows how this works. The problem is it doesn't work for multiple arguments, and console log is designed to accept any number of arguments. So that's why I implemented this one, where I said a spread operator in this means that I'm going to accept a variable number of arguments. I would like JavaScript to hand it to me as an array called args. So literally args is an array. So you can say arg0, arg1, arg.length, what all those things. So that's what this stands for. Now, once you get that as an array, you can call console.log.apply. For those who don't know what apply is a prototypical method of all functions. Any functions you can call .apply on, and it takes two things. One, first argument is the this object, which in this case is irrelevant, so I'm passing null. And the second is an array of arguments, which conveniently, if I didn't want to do anything special, I would just pass this, because args is already an array. But that's not, I want to prefix that array with the timestamp. So that's why I unroll the previous array, spread it like that, and in front of it, I put the timestamp. So this is the logging function. So, I mean, if you are new to JavaScript, this would be helpful. Now, so that's the logging function. This can help you write wrappers for any kind of other function. You know, do something before, blah blah blah. Here, do something, do the actual action, and then do something after. And you know, you can do it like this. The delay function. This is probably more to the point of this meetup, which is how do you use the promise API to create promises that are not already promises, right? So asynchronous activities, turn them into promises. So most of us have used set timeout, and you can say set timeout, do something, which is a function, and then do it, but do something after 5,000 milliseconds, right? This is the standard set timeout. So that's exactly what I'm doing, except, so I'm saying this delay function basically returns a promise that has a built-in delay of whatever milliseconds you passed in. So the way it works is it returns a new promise, which I said that in the beginning. But whenever you want to return a new promise, inside the promise wraps a function, and that function takes two arguments, resolve and reject. I'm not using reject in this case. So just imagine that it's resolve. And now you're going to resolve. It's not going to fail, basically. It's guaranteed to work because I'm not rejecting. I'm just putting the log that this is just to tell others that I'm about to delay for n number of milliseconds. And then you go into set timeout. To set timeout, you're passing in this callback. This callback is going to resolve to a value of undefined because I don't intend to actually return any value. I just want to delay by that. And it's going to do that, not right away, but after this n number of milliseconds. Okay. So set timeout, as you know, will basically wait for this long and then eventually resolve. So this is a good way to create an awaitable delay. Okay. So the rest of it is standard. Okay, now let me run this. And there is a problem that I can probably use some help on. All right, so I'm running this. It says waiting for orders, delay, and your website is getting an order every 5 seconds. So it took you a second to pack the order and another second to ship the order. And then it went back into waiting for orders, and then the same thing repeats. So every time. Okay, so if your website, just to show something, if your website was getting an endless stream, continuous stream of orders, that means there is no delay between those to get an order. Then let me just comment out this line to simulate. So now waiting for order has no delay at all, so it just happens. All the delays in packing and shipping, right? On the other hand, if you had no delay in packing and shipping, then as soon as you get the order, it gets shipped. You'll see. No order so far, but as soon as the order comes, it will get packed and shipped instantly. Wait, what's happening? Huh. Oh, all of them took that time. I'm not sure what happened. Why?
Hey guys, I gotta go. I haven't eaten dinner yet, so I really enjoyed it, and I'll see you guys next time. Thanks for hosting this, David.
No problem.
All right, take care, guys.
Have a nice evening.
Thanks, bye.
Bye bye, Jitesh.
All right, so that was interesting that it just sat there for 15 seconds, got all 3 orders, and then
Shipping them all.
so what happened there?
It's like adding the delay.
Wait, delay
Still have
5
it.
seconds. Oh, it's sorry.
Right there.
What? What is
The
it?
delay the delay 5 seconds on line 21.
Line number?
21.
Yeah, I am on line 21. What's the issue?
Why
Why
you're asking
Why is it not yielding after after 5 seconds? Why is it yielding all 3 of them after 15 seconds? That's the question.
Getting all 3 orders at once.
Exactly. You saw that. So if you see here, well, let me do one thing. I'm going to do a log of starting, so that we have a timestamp of starting timestamp. Let's do it again. Starting, and instantly it went into waiting for orders. So they are the one that's the same. Oh, now look,
So now
it went. This is different. This is what I was expecting originally.
yeah.
Okay, it's behaving the way.
Run it one more time.
Hmm?
Run it one more time. Okay, there it is. Yeah.
Yeah, it's doing what I thought it should do, which is every 5 seconds an order appears,
Yeah.
and then it gets packed and shipped immediately.
Yeah.
So even then, okay, so that problem, I don't know why it was there earlier and now it's not there. I have no idea, but there is a different problem that I want, that I couldn't fully understand what is happening and why is it happening, which is, why does if there were 3 orders, is there a way for me to pack and ship them in parallel?
I can ship them in parallel. Can you
Yes.
promise that all? I mean, or am I
Uh,
thinking-
Yeah, you could use promise.all. There's also there's a framework called there's a library called the Async library as an example, and they have a function that you could use to do stuff in parallel. But I think the easiest way is his suggestion, which is to just use the promise.all.
Excellent. So let's try it. So that's what. So if I had some 3 people packing, or any number of them, for
Yeah,
that
yeah,
matter.
you would have 3 orders that are.
Yeah, and 3 people shipping,
Yeah.
right? So
No, I understand the logic. Yeah.
so let's see. How do I do that? Help me. How to model it?
So
Are we? Oh, by the way, one of the goals is, of course, to educate the community and everybody. So are we losing you?
No, I'm fine. Like this is real fresh for me. So plus it's I need JavaScript. I'm good.
Okay. All right. So yeah. So how would I combine these? So I obviously do. I am getting promises. The question is, how do I do promise.all on? Well, the orders are not coming any sooner than every 5 seconds.
right.
So how would you even
It would
collect
take.
it? Imagine if
Well,
if they were coming super fast.
Yeah, if they're coming super fast, if you remove the delay, then
Let's do that. Yeah.
because if you didn't remove the delay, then it would take all 15 seconds for the promise.all to
So yeah, see this.
execute, right?
This is still taking 1 second for packing and 1 second for shipping.
Yeah.
So
So you just do, I don't remember the exact, click promise.all, and then you're gonna do it on your orders, correct?
Yeah, so the way promise.all works is that it accepts an array of promises.
Yeah.
And so what you do is you would get all like
I should
3
remove
promises.
408.
Yeah.
Yes.
I should remove the await for await. So in this back order, let's say,
Yeah.
if I make it for,
On 28, yeah.
right? So now order is a promise. Order is not the order.
Yeah.
So let's call it a
But
P order.
get
Yeah.
orders is still a
Right?
still a generator, right?
Yeah, but that's okay. If something is a generator, I'm assuming that it will it will start return. If you don't for await on it, you are getting a promise. Am I
It's an
wrong?
unfulfilled promise, correct? Or,
That's correct.
yeah.
So yeah, so let me see.
Promise that all in your order. And I
Yeah,
think-
so my theory is, right. My theory is that if I start calling this P underscore order,
Yeah.
which means a promise of an order, not an order, but a promise for it. And then you were doing,
space.
huh?
Make a new line. Promise dot all. I think it's capital P, right? Or no?
Oh, yeah.
It would be
It's capital P. yeah.
capital P.
Yeah,
if you're referencing, yeah.
So, but the thing is, we don't have an array yet.
You'd have to collect all
Yeah,
three, but instead of
exactly.
yielding them, what you do is
Exactly,
you
yeah, yeah.
collect them into, let's say, like
So-
an internal array,
Yeah.
and then pass that array into promise.all.
So what we should do is, we should say for, and then we are collecting it into an array, right? So we say let orders,
Array.
const orders is an array, empty array, let's say. And then you put all of these, which is orders, order promises actually. These are not even orders, these are promises for orders.
Yeah.
P orders, right?
Yeah.
P orders
Then dot
dot
push.
push.
Yeah.
P order. I should say, no, it's not a promise for orders, it's
It's
promises.
an array.
Promises of order. PS, promises. So promises of order, right? And then you put the order in there. Okay, so you got your promise for
Now you
order.
can do your promise dot all. Yeah.
Sorry?
I was skipping the stuff, but yeah, you can do your promise. dot
Yeah,
all.
so now I say PS order dot, so promise, oh, sorry,
No,
promise
it's
dot all,
promise,
yeah,
yeah.
promise dot all, this. Now I can await them.
Well, yes.
Yeah, because otherwise, this is the then, right?
Yeah.
So I just put an await is better, right? So now the question is, oh yeah, then I'm yielding them all together. Am I even yielding anything? I guess I am.
I don't really understand yielding quite yet, because I just got.
Yeah.
So the whole idea of a generator is that you can actually there's two ways you can return something in a generator. So if you denote your function with the asterisk at the beginning of the name, yeah, you have the option of doing either return or a yield. What a yield will do is, let's say you know you're going to be returning 10 values, 10 different values from it. What you can do is you can do yield for the first 9 of those values, and then when you're done with the last one, you can do return. And on the generator itself, it actually is not returning just the value, it's returning back a structure, an object that has a property on it called next, I believe. And the next is, in other words, if you have something, if you have another value that's available, it'll let you know that, yeah, there's gonna be another one, but when it's done, it'll say false for that. Yeah.
By the way, we didn't need it to do it because we kept yielding, and at the very end, when we run out of stuff to do, we return from the function, like end the function, right? And that ends the for loop also.
Yeah.
So we got the same effect, basically.
All right.
So we await for promise.all, which means we are waiting for every order to
Yes.
in the world, basically.
So you
it
don't
comes
need
to
to
us.
yield them, correct?
Huh?
You don't need to yield them, correct?
No. So the question is here, this yield is for whoever is awaiting on me. The question is, do we need to? No. What we could do is we could return this promise.
Right. That's kind of what I was thinking, but.
Yeah, but when are we going to do the packing?
True.
So I think,
Maybe it is needed. I just need some more repetition with it, really understand the deal. Yes.
so what I wanted to show was, okay, this is fine. Well, even if we undo,
See if this works.
sorry, yeah. Let's do that then. Obviously, there is no such thing as order.
Not anymore, no.
Yeah, so we need to, oh yeah, this. Const orders is equal to out. Yeah, this will give us, right? Yeah. This will be an array of orders. And then we just say for const order of orders. Yeah. Then, oops, sorry, I'm to the end. Array of orders, and then that's what I wanted to do. Okay.
Yeah.
So yield order. Okay, so you're waiting for all the orders to arrive, and then you're still packing them 1 second at a time. So not sure what we gain, but okay, let's see. Let's give it a try. What happened here?
Boom, boom, boom.
Oh, it had no
Okay.
promise rejection warning.
Okay, get orders is not a function, or its return value is not iterable.
You guys have a restroom?
Yes. Handle this wall.
So I think it's, well, it's, of course, it's your get orders function, but I think because maybe it doesn't like the fact that it's a yield that you're returning.
That could be, yeah.
But I don't know
Yeah,
enough
yeah.
about yield to know that, that's what I would assume. But that's
So
why I
you're
think-
right, it doesn't. So I thought that so you said it's not iterable. So basically, if you are going to call a generator, you got to call with for await. That's the only way it will work. So anyway, I think we should stop. It's all past 8 o'clock.
Yeah.
But yeah.
I mean, yeah, I should think about this and do this all night, but yeah, my dogs will be really mad.
All right then.
All right, I'm gonna go ahead and
This
stop
is-
recording.
Okay. All right, we'll stop. Bye bye. I don't know if there is anybody there actually.
All right.
Now there's not.
I can hit end, right?